Welcome to the online CPD series called I Thought I Knew, where we interview industry leaders in order to understand their tools, tactics, and techniques and convert these into actionable habits and processes that you can immediately implement in order to better your service as an architect. Today's topic is I thought I knew how to design buildings that are designed to be water efficient. Our guest is Gerry Brink. He is the pioneer behind Surplus Water 2025. His aim is to educate everyone to understand, manage, and conserve water consumption. South Africa is the 30th driest country in the world. It is estimated that we will be a water scarce country by 2025. That is really soon. That means all South Africans will have to make a mind shift as to how water is consumed. Gerry created a company called Aquafection, where their main goal is to equip everyone with the right knowledge to consume water efficiently. He is a qualified mining engineer who completed his MBA at the University of Stellenbosch. I'm going to tell you why I thought I knew how to design with water. I'm going to share my screen with you. This is the design of a water system of a project I was involved in a couple of years ago. It's a high-rise or 4-story high-density accommodation building where we included the water as part of the design. So the building was designed to have water storage facilities at the top, hidden behind, well, inside the roof structure. And it's divided into two parts. It has a west wing and an east wing. And then it is split with an emergency escape staircase that it shares. So let's go through the details of this design. I'm including it because it would have really helped me if someone had taken me through a drawing like this before I had to do it myself. On this project specifically, I had the privilege of having a great boss who gave me the freedom to learn, yet watched over my shoulder to see that I don't make mistakes, and where I made mistakes to guide me to understand the systems and this large project. It was a rather large project. Let's go through the details. So if you view it as an abstract elevation, then you'll understand it easily. This is the water supply underground, the main water supply. Then the fire water is indicated in green. There you can see it's an emergency escape staircase with the hydrants and the reels. And then on the top floor, we reticulated it into the other two staircases of the building. On one of the blocks, we have a large backup tank. This is a backup tank in this system where we combined it with the fire water. So it's on the highest block of these residential units. That this is a far bigger tank, so that if there ever is a water cut, there would still be backup fire water in the system. Then let's go through the more domestic fittings. We had 2 stacks going up. There you'll see it. This client has a lot of requirements in terms of meters and shut-off valves that must be installed on the ground floor. That makes it easier for them to isolate these systems if they have issues and to service it then. We coincidentally also have shut-off valves at all the fittings. So when they do maintenance on some of the fittings, it doesn't affect everyone in the building. The municipal water then feeds most of the fittings, the showers, cold directly, the zinc and the wash hand basins, and then it goes right up into the roof where we had a hot water system that links to the solar panels on the roof. This then creates a ring feed, so the occupants don't have to wait long for hot water, also reducing the water consumption of this building. The next one then is where we supplied, well then the municipal water, here you can see the municipal water splits into this backup water tank, which is then kept full with a ball valve. This is big enough to feed the toilets and one wash hand basin per, one wash hand basin. The toilets were grouped together. So where the toilets are, there was a wash hand basin. And those were all linked to this backup water system, which then fed these fittings by gravity. So even if there's no power, no water, you would still have backup fire water and your sanitary requirements would be met for a full day. We also had Italian toilets imported and installed because they use only 6 liters of water to flush to reduce the consumption. Again, well, those were the ones we could find. They were not as freely available as they are today. And then we also engineered and developed a tap for the showers that would reduce the water consumption. In these buildings, the client's biggest concern was that the occupants would open the showers and go watch TV. So the whole bathroom would steam up to create a warmer environment. But obviously the consumption on that is huge. So we designed a tap that is a push tap. And then every 20 seconds, one would have to push that tap again in order to reduce the water consumption of that building. That being said, I really thought I knew how to design a building that is water conscious. And that's why I've asked Gerrie to do this interview with me, so I can see if I'm still up to scratch. Am I updated with what I think should be done? The main things you will be able to do after this CPD, after the interview with Gerrie, is you will be able to understand what are the 20% of things we as architects can do to get 80% of the effect. You will be in a position to confidently advise clients on how to deal with water systems in any building. Thirdly, you'll have a more comprehensive understanding of how the water consumption system works and what our role is in terms of reducing water consumption and contributing to water conservation. A lot of con words. And then there will be actual practical items that you can apply in all your projects to ensure that your clients get the best possible service from you as an architect. I hope you enjoy Gerrie as much as I do. So welcome, Gerrie. Welcome to today's presentation. Let's start off with what is #SurplusWater 2025 and what role can architects play in this?
Thanks, Anneke, and thanks for the opportunity. The #SurplusWater 2025 comes from when I started this business back in end of 2015. I was halfway with my MBA, and I did my thesis on water efficiency or factors influencing water demand in commercial building, especially toilets. And part of the background studies and the research was all the where do predictions say we're going to be in 2025, 2030, 2050. And across the board, all predictions from various sources said that by 2025, we're going to be an extreme water scarce country. Now, currently, we are the 30th driest country in the world. And predictions are, like I said, that by 2025, we're going to be an extreme water scarce country. So with what we're doing, I thought, what can we do to actually turn it around instead of having a deficit, but to have surplus water? And it's actually quite easy. And the reason for the surplus water is obviously you have to have a goal that's bold, and it must be in a reasonable time frame to be achievable and to be a bit of a stretch. And I thought, obviously anything beyond 2025, most of the people in business now is going to think, I'm going to be finished with it, so let's leave it for the next generation. And anything too soon is just ridiculous. So it was a good I think it was a good measure and just to say, instead of being an extreme water scarce country by 2025, is to turn it around and to try and have surplus. Now, if you just look at, I'm going to show you a quick graph and why also 2025. In Gauteng as an example, Gauteng is fed by the integrated Vaal River system. Now, I just want to quickly share my screen here. Can you see that this whole Vaal integrated, Vaal River integrated system, and it's quite a substantial portion of the South African catchment area, and it feeds the whole of Gauteng. Now, if you look at the graph on the right hand side, if you look at the red line, that is the supply yield from 2010 up until predicted 2050, and you'll see it levels out from 2026 about, and then again from 2031. Now that dates is when there's a next Lesotho project coming online, and up to then you'll see the supply from the integrated Vaal River system is actually fairly fixed. The blue line on top of it is the demand. Now where we are now, you can see that the demand is 15% higher than what it is, than what the Vaal River system can supply. Now this is quite scary, because it means that no matter how much it rains in the Vaal River integrated system, we don't have enough water. We're using much more than what can be supplied in Gauteng specifically. But I mean, that's the case across the whole of South Africa. We've got about I think 40% of all our water catchment area falls on 8% of the country. You know, so it's totally skewed on where we get our water from the natural water cycle, and where it goes to. And if we get permanent rainfall in a good rainy season, we're already in trouble. It's like paying a credit card with a credit card. There gets a point where you're going to run out. And with Gauteng, Pretoria is growing by 10,000 people a month. Joburg is growing by about 20,000 people a month. So that problem is not going to go away. So if you look at that graph that I showed, that the getting to surplus is actually just closing that gap between supply and demand.
So the gap between feed and demand at the moment, how is that made up?
That is, I think if you look at the demand profile for South Africa, 67% is from agriculture, and 23% is from municipal supply. So that's basically commercial buildings, everything within cities, that's residential and commercial buildings. And obviously, I think of that 23%, more than 90% is from commercial buildings. So the focus from my study was to look at commercial buildings, because agriculture and mining is huge. We're not going to go there, but we have to go there eventually. But I mean, that's not the purpose of this discussion, is to focus on the commercial side, the municipal side, where residential, commercial, retail and industrial falls within. So to look at that deficit between the supply and demand is actually coming from an engineering background. It's not just having a hashtag, let's do something nice and green and get to surplus water. It actually needs to be measurable. If we cannot measure it, it's useless. Then it's then we might as well leave it, and it's just a fad that's going to fade. But how are we going to get there? If it's what gets measured gets managed. Exactly. And it's actually quite simple. So our whole approach is, and maybe we'll get to a bit more detail on how we're going to get to the surplus water. But just that's the background, and what we do as a business. We've seen that by measuring demand, you could identify key aspects that influences your demand, and you can focus on that key aspects. And by knowing what your history was and focusing on what you can do, you can actually create, close that gap in your personal capacity or in your business capacity. And when you start measuring that, you can actually say, we are now saving 25 liters per day, and cumulatively since we've started, we've saved this and this and this. So this is our contribution to surplus water 2025. So that's the whole idea behind that. behind the initiative.
That leads me to the second question is, what are 5 practical items we as architects can include in new buildings that will help us contribute to this whole concept?
See, what many people do make a mistake with is we focus on the supply side. We say, let's build a bigger dam. And architects, engineers, and municipal management say, it's nothing we can do, we need more dams. Or like Cape Town did, we need the desalination plants. This is our current demand, we need bigger supply to actually supplement our demand, which is totally skewed. We have to go all the way back and say, let's focus on the demand. Why do we want to implement a bigger dam or rainwater harvesting or a borehole system to supply an inefficient network? So the whole focus is to first focus on demand and not focus on supply. And as an architect, as an engineer, as a business owner and manager, that's where your power sits in what you can do about the demand. And it's actually fairly easy. And I want to, just as a background with the Surplus Water 2025 and answering this question, is we've got the drop principle. I just want to show you the what it looks like. And just for it, well, it's a registered trademark. I just quickly want to show you the nice logo of the Surplus Water 2025. I don't know if you can see that.
Yes.
So it's a registered trademark. It doesn't belong to any company, and anybody can get involved with it. But what I want to show you is the drop principle. Now the drop principle, and that's not to jump into what can we do, 5 things that we can make a difference, because 5 things in water differs for any building. There's not a silver bullet in water that you can say, this is the 5 things, if we do that across the board, everything's going to be fine. They correlate, more or less, but you have to follow the right approach to get to that whole 80-20 principle of saying, what's the 20% that we can do to get to the 80%? And if you look at this whole drop principle, the background is understanding the data. Now that data is, what is your history? Whether you're a homeowner or a business owner, what do you consume? Get to that number. What's your kiloliter per day number? What do you use per day? And it's fairly easy to determine that, say, what was a meter reading a year ago? What's a meter reading today? What's the day's difference? What's the consumption during that days? And you can get to a kiloliter per day. And that's the baseline. If you can't get to that number, there's nothing to measure yourself against going forward. So once you've got that data, the first thing you do in any situation and in all situations is to install electronic monitoring. Now that's where the measure parts comes in, is to start understanding if you're a historic 100 kiloliter per day building or consumer. Once you install a logger, you start seeing what that 100 kiloliters comprises of. Whether it's a constant flow, what we call a minimum night flow, when a building is closed, say from 6 o'clock in the evening, a building is closed and it only opens up 6 o'clock in the morning. During that time, there's supposed to be 0 consumption. If there's any consumption, we call that a minimum night flow. So then you can determine, listen, with this building has got a constant flow of 100 or 200 or 1,000 liters per hour. And that's when you get a refined view of what your 100 kiloliters per day comprises of. From there, you can determine the options. From there, you can determine what's the 5 things or the 1 thing or the 2 things that we can do to actually get this building more efficient. Once you get
let me understand. When you insert those loggers, these would actually be installed on the different pipes in the building to see what the flow is per pipe, or is it something you do at the main water connection? Where do you do that installation? It's
actually the quickest, easiest, and most effective, cost-effective way is to install it on your main incoming meter. Whether it's the bulk council meter, you have to get, obviously for a big commercial building, you have to get permission from council to do that. I know City of Tshwane, City of Joburg don't have much issues with it anymore. They used to be in the past. Or many of the clients...
Sorry, So let's just mention the other big metropolitans as well. Cape Town, do you have issues there?
Cape Town in some areas, and it's
okay.
Cape Town is a difficult one because they're very open for assistance from public and from everybody that comes to the party. But there's obviously certain areas that they're a bit more. The big issue with installing loggers on a council meter is not necessarily because you can install it on a meter without tampering with a meter. It's physically a reed switch that fits on top of the meter, manufactured by the same manufacturer as the meter manufacturer. So it's not tampering with a meter. But some of the people don't like it because when they do have to replace a meter and there's a third-party logger on a meter, they become legally liable and they don't want to get involved with that stuff. You know, so there's actually just some legal issues. eThekwini, Durban, KZN, they currently still, there's no way you have to follow a quite extensive process to get a logger onto a council meter, and it will only be for a short temporary while to get readings, and then you have to actually install a check meter.
Is there another way then? Can you install it on a different location in the pipe network?
Yes, what we then normally do.
Get that access.
Yes, because if you've got an old council meter, there's obviously some of the meters cannot be logged. Most of them you can install a logger on most meters, but some of them is old and cannot take a reed switch. What we then do, or when we cannot log the council meters, we install a check meter, a bulk check meter just down the line, downstream from the bulk meter, and you install your logger and your equipment on that. Then you know it's your property. You can do with it what you want, and you install your logger. Because then it gives you, with one logger, it gives you a pretty good idea of your whole building's consumption. You pick up the irrigation flows, you pick up the all the consumption in the building. If there's one toilet leaking at the security guardhouse or on the top floor, you can actually see that. So that's the best way to get a good view of the building, because obviously your historic consumption, that 100 kiloliter per day, is something that you get billed on. So you want to understand where that comes from before you start fiddling with sub-meters to go and refine something before you actually understand the bulk of the problem. I don't know if you can still see my screen. So this is, if you look at, once you've installed a logger on a meter, you're going to start seeing a profile. Let me just zoom into that portion. This is a normal profile for a building over 3 days, from the 1st of March to the 4th of March. And you can see it makes certain spikes. So this site has got a backup tank. You can see the spikes. The tank fills up every now and then feeds the rest of the building. And if you look at 1:30 in the morning, there's still a flow of 152 liters an hour. So there's a definite leak. You can see that this site never goes to zero. So you can actually see this site's got 152 liters an hour leak, and there's already a understanding of, if we can sort out this leak, we're saving this site 10, 20, 15% of their consumption. Funny thing is, it's not necessarily a leak, but it can be 150 liters, can be one toilet somewhere running at a pretty slow pace.
Just in terms of the projects you've been dealing with, do you get to sites where 10% of the sites have a leak or zero, that overnight flow rate, or is it a 50% thing, or most buildings have running water they're not aware of?
Okay, the shocking stats is, and it's not a thumbs up, we've got quite a lot of sites varying from office buildings, schools, private schools, tertiary education facilities, retail shopping centers, the whole array of commercial and industrial buildings. And I think there's not 5% of the buildings that we found that didn't have any issues.
95% of buildings have an issue.
Exactly. If you look at the water reticulation in the country, we're losing 37% of our water before it gets to a bulk meter. They call that non-revenue water. So 37% of the water in our network in this country is lost before it gets to a meter, 37%. From there, looking at all the buildings that we've logged, there's still room for 50% improvement from leaks, from toilets running, from all that stuff. So in effect, in Gauteng, specifically Tshwane, the real losses in the network is 82%. So 82% of water coming from a waterwork, bulk waterworks, is lost, and there's only 18% actually ending up with the intended purposes of doing what it's supposed to do. Now, if you look at my screen, this facility now in lockdown, you can see there's no, this is live data. This is for the last 24 hours, for the last week. You can see this facility is running at 200 liters an hour. Now, 200 liters an hour sounds a lot, but it's actually invisible. Now, if you look at you can switch now on the total consumption for this facility per day, and they use 5,671 liters a day with nobody there. You know, and you calculate that at 35 Rand per kiloliter in city of Tshwane, 73 Rand a kiloliter in city of Joburg, which is double that of most of other municipalities because of the way Joburg is built on a watershed. All the water at Joburg is pumped upwards, and that's why it's double the cost of all other municipalities. But you can see this site is losing almost 6,000 liters a day with a small leak of 200 liters an hour running like that. And you think you'll see 200 liters an hour, but that's one toilet somewhere running at the back of the bowl without people even seeing it. One toilet. Now take a school where you've got 10 toilets with small buttons getting stuck and stuff, and you easily run on 2,000 liters an hour. Right through the day, sitting with a school with a 80,000 Rand a month water consumption, we changed the toilet flushing mechanisms and we dropped them by 90%. You know, so the waste component in water is immense. And I want to show you something on this specific facility the week before the lockdown. If you look at this profile, look at that water running at 11,000 liters an hour. And it's invisible. Water gets its way it finds its way to the closest stormwater route of least resistance, and you won't see this leak would have run for months and only being picked up on a council meter after 2, 3, 5 months when they take an actual reading. And if you look at what the actual consumption per day was through those leaks, there 269,000 liters lost, and it's not visible on surface. You know, for 4 days, there was more than 1 million liters lost, and it wasn't visible on surface. And we wouldn't have known about it if the monitoring wasn't there. So just to get back to your initial questions of the 5 things that you can do, is actually not that. It's a bit of a loaded question, and you can only know what that 5 things are if you've got the monitoring in place. You see if it's irrigation.
Just let me stop you there. How much would it cost my house to have this monitoring system installed?
It used to be not very cost effective for residential properties to do monitoring, because you've got water meters that's outside of the house. Most of your water meters, it's unlike electricity, it needs to have its own power source, and it needs to have a GPRS or a SIM card to send the data, or a radio frequency, which made it quite expensive. But now in the last 2 or 3 years, the whole Internet of Things, the development of the LoRa Sigfox devices and Internet of Things devices, we've come a hell of a long way in the last 2 years, where we've got cost-effective devices for residential meters that's going to cost you about 1,500 Rand once off to install it on your meter, and you get the same data on this platform that I've shown you at a cost, I think, of about 40 Rand a month or something. But the data and the info you get from this is, you cannot calculate it. I mean, you in a residential setting, if you've got a toilet running, an outside toilet, with a leak that you cannot see, you must physically put a piece of toilet paper at the back of the bowl and see it getting wet. That's about 10 liters an hour. You know, so for 24 hours, that's 240 liters. For a month, that's almost 750,000 liters. So that small things can actually put 2,000, 3,000 Rand on your bill in 1 month without you knowing where it comes from.
Okay, so after lockdown, will you send someone to my house, please? My husband says it's fine, he'll pay. Yes, please move on. Sorry for interrupting you. So for 1,500 rand, you can do it at your house. Let's say I'm sorry for putting you on the spot about these costs. If I want to do it at a school, for instance, is it similar cost, or is that a bit more elaborate?
Yeah, it's a bit more, because obviously you've got a small plastic domestic meter at your house, which takes a small reed switch on the side, and it's fairly uncomplicated. You can do the same logger with schools and commercial buildings, but you've got bigger meters. So it's with a bigger meter, it's a different reed switch, and that reed switch, some of them are up to 2,500-3,000 rand for the reed switch alone. So what and the data integrity, or not the integrity, the frequency of the data. This cheaper logger only gives you a reading every hour, which is fine in a domestic sense, because you get an update and a flow profile every hour. But the ones that we use in the commercial side and schools not as much, but of the bigger commercial buildings, we get a reading every 15 minutes. So you get a much more refined data and profile to make a call, and to say, when you get something down to 100 liters an hour, you want to see every 15 minutes there's a reading, and you don't want to lose any water. And those loggers, commercial loggers, is more in the line of about 15,000 rand a month. 15,000 rand once off, and then you're looking at about 150 rand a month subscription fee, because I also run on a GSM SIM card. Okay, so the data was you've got a 100 kiloliter per day facility, or a 20 kiloliter per day facility. You've installed a logger, and you can now see, okay, we've got 10 o'clock to 12 o'clock at night, we've got a spike every night, so it means it's irrigation. We've got 100 liter an hour constant flow, so there's either a leak or a toilet running. So you can now, if you move to the O, which is options, that starts giving you options. What's the option? Is it a leak, a big leak? Does it come and go? Normally a leak is something that's consistent. It runs at 100 or 1,000 liters an hour right through the whole time. If it's a toilet, sometimes it gets stuck and it runs at 400 liters an hour, and it goes down again as somebody uses the toilet, or cleaners come in and they reset the toilet, if you want to call it that. A toilet is something that comes and goes. We've had buildings with I'm not going to name any names, but certain toilet flushing mechanisms that's prone to get stuck, and they run at between 400 and 600 liters an hour. We've had a site where that thing gets stuck Friday afternoon, it runs right through the weekend. Monday morning it's reset, and you've lost 40,000 liters over the weekend. And it's with our system, with the monitoring, you actually get alerts and alarms every morning that says, listen, you've got a leak on site, please just investigate. So going to that O portion is where the 5 things that you can do to actually do something. And it's not 5 things, let's implement this 5 things and it's done. You start one thing at a time. So if you see there's a toilet, let's do, there's irrigation, we investigate the irrigation, we find a leak, we fix it. You immediately see, within 24 hours, you see the effect of what you've done. Then you move on to the next thing. And that's where the P comes in, where proceed. So you identify an option, and then you proceed to go and do that. And that immediately is got an effect on your profile. So it's a positive reinforcement, a positive feedback loop. So you do one thing, and because of the monitoring, you actually get the feedback immediately to start implementing the next thing. So what we normally do is you can pick up if there's irrigation spikes. If it's an automated irrigation system, you can see exactly the Monday, Wednesday, Friday, or every day between 6 and 8, or 4 in the morning to 6 in the morning. And you can see that volumes, and you can say, listen, but this area, this is the square meterage of the area, we're over irrigating. So let's just reduce it. It's not change our automated irrigation from 15 minutes to 7 minutes. It's as simple as that. And you actually, because most of this, we've got sites that's 80% of their consumption is irrigation, and it's automated irrigation running at night, and nobody knows about it.
From an architectural management point of view, what normally happens is we get appointed as architects, and then landscape architects get appointed for their part of the work. But I mean, I've never actually tried to find out how much they irrigate or how many irrigation points they install. Never been involved with that, and I think of a value add to clients. It's a good thing if we question these types of systems that are being implemented.
Yeah, exactly. I mean, it's actually so the number of irrigation points, and none of that matters as much as monitoring your irrigation. To know, listen, we've got 100 square meter garden. We need 25 millimeters per week per square meter, and that's the water we're going to use. So set up your automated irrigation to monitor that. Because what people do is they irrigate for 15 minutes on each zone, and that's what we do. Where it's a big office complex, 80% of the consumption is irrigation, and that's been like that for many years. So that's what they pay. And the issue with water up to now was it's available and it's almost for free. You know, it's dirt cheap and it's always available. So nobody really cares about water. Where it's not renewable like energy. Once you've used it, it's dirty and it needs to go through certain either man-made filtration or a whole water cycle to get clean again. And the knock-on effects of wasting water is we making it so dirty, the volumes, that our wastewater treatment plants cannot handle it anymore. And we're wasting good potable water that in Joburg costs a hell of a lot to produce. We're wasting it on inefficient irrigation. So irrigation is one of the big components. Second one is inefficiencies in the building. That's where a patented toilet flushing mechanism of us comes in, and that can make, in commercial building, can drop your site's consumption. Where if everything's in place, if you've got a building with no irrigation and you don't have a water-based cooling tower, and it's basically just an high-rise office building, 90% of your consumption is toilets, and that's when 90%.
Take us into that flush mechanism and how it works, what it costs, what influence is. For me, I've never specified a flush mechanism. I specify a toilet based on what it looks like.
Yes.
It's the ever popular Gibber systems because it looks pretty. I've never given any thought. There are those fittings that say they are water saving, which we've specified before. Yeah. But I must say that's not the key element I consider when specifying toilets. And as architects, we specify hundreds of toilets every year. And we don't feel obliged to specify something that is more water conscious. So exactly. Please take us through that mechanism so we can see how we can implement it.
I mean, obviously from your approach is all about the aesthetics, not necessarily, obviously functionality as well, but it needs to look pretty and work. If it looks pretty and it works, then everybody's happy. But if mentioning, so I could have been an architect.
You could have been an architect.
So if you look at Gibberet, as you mentioned, the nice thing about it is it's aesthetically pleasing. Most of the mechanics is either in the wall or behind the wall. You've got just one nice big silver button, and everybody wants to press the big silver button. But the whole background, and I'm speaking. This is my opinion, is where it comes from is it's a space saving mechanism as well. I mean, that whole in-wall system is designed to save space in Europe and places where we've got limited space. We don't have necessarily that issue in South Africa, and most of our retail and commercial buildings, you've got that cavity behind the toilets where you can do anything behind that cavity and still make it look nice in front. So there's no need to put in a 3,000-4,000 rand toilet when you can do a 300 rand plastic cistern at the back of the wall, also with a nice big silver button through the wall. Because what you design the aesthetics for how it looks for the consumer, for the client. But you have to look at the maintenance and obviously the capital cost. If you can have the aesthetic and the functionality in the front, but a fraction of the cost, OPEX and CAPEX at the back, not just cost, but ease of maintenance and long-term, then it's a win-win. So you still have, but it looks exactly the same as the nice one that you spec, the 4,000 or 5,000 rand one that you spec, but you're actually only putting that nice big silver button in the front with a normal old school cistern at the back.
So what are the details of this flush mechanism?
It's actually, Anneke, it's scary how cheap and cost effective and operationally effective the change is. If you look at any old cistern, most of them, Dutton Plastics is the manufacturer of this flushing mechanism. And they do various ones. They call this one the Super Flush Light. And if you open an old cistern, you'll see this mechanism on the inside with the 3 pivot points clicking in. And that's basically, they call it your outlet valve. Now, how this thing works is if you pull the lever or push the button, you'll see this mechanism moves up and the water flows through there into the pan and it clears the pan. And it will only empty the cistern and then it drops back. So this black component in the middle, if you look at that component, it's basically filled with air and it floats on the water until the cistern is empty and then you empty the cistern. So some of the new cisterns, the water efficient, high efficient, they call it HETs or high efficiency toilets, which is the dual flush, the top flush buttons. They normally either a 6 or a 9 liter cistern. And either, I know, if you ask people which one do you press, the 1 or the 2 button on top, they normally just push everything. So I don't know what's it for, so that thing doesn't work. So you can either have that top flush or the front flush, and when you push it down, it empties the cistern. Now that high efficiency toilets is 6 to 9 liters, but you get the old ones in all facilities, that's 27 liters. Now, if you flush this thing with a 27 liter cistern, it's 27 liters down the drain. Now, you don't calculate the consumption of a toilet based on the number of toilets on a site. You calculate the consumption of the toilet based on the number of people on the site. So you can have one toilet with 10 people. 10 people go to the toilet on average, or a person goes to the toilet on average 4 to 5 times. So if you've got 10 people in an office going to the toilet 5 times, that's 50 flushes. 20 liters, 50 flushes at 20 liters, that's 1,000 liters, just from 10 people with one toilet. But now you get sites with 10 toilets and only 10 people with the same amount of consumption. So that's why we use the amount of people and not the amount of toilets. So now you've got a 27 liter cistern, you've got this flushing mechanism, and every flush, every time, for the 4 or 5 times people go to the bathroom, it's 27 liters down the drain. We've had a office building that they used to, it's a well-known office complex. They used to consume about 30,000 liters a day. And we started our intervention and we did the conversion from this one. Now, this is the change we've made to this component. So basically, we've changed these 2 components with this one. So it's a very simple retrofit with toilets that's already fitted with this devices. It's a 5-minute change, and that takes that 27 liter cistern. Now, if you pull down the handle now, it will lift this. If you leave the handle, it will drop back. And with the design of this, the increased flow actually has got a bit more force down the pipe and into the bowl, making it a 2 liter flush and not a 27 liter flush. So that's a 90% saving on some of those old cisterns, just by changing this mechanism that's going to cost you about 150 bucks.
Can any toilet get this? Is it only some toilets? You found some old toilets that can't take it? All new toilets? How does it deal with the Gibberet system?
There's the Gibberets we can't do anything about. If it's an in-wall system, we can't change it. If it's a flush master that's coupled directly to a pressure fed from a main line, we cannot change it. So if it's a cistern toilet, any cistern, old or new, whether it's a top flush, a front flush, you can change it. You can either change this mechanism, or you can change the whole outlet valve. So you take out of the closed couple cistern, you put in this new outlet valve, and Bob's your uncle. But that's a 20-minute job when there's an old outlet valve in there.
Sorry, can a normal plumber just come and do it at your house today?
Yes, what we're looking at partners, and we've got a training leg in the company as well, just to train people on how to do this mechanism. The nice thing is it's a Dutton Plastics DPE. It's our patent. We've come up with the idea. We gave it to them because they've got the network, and it's based on their old super flush. So that's why it's called the super flush light. And you can see it bears the Surplus Water 2025 logo. So it's a Surplus Water 2025 efficiency device, and you can buy it at any shop, and you'll see from that there's a QR code that will show you how to do it yourself. So if you've got a husband or something that's not totally useless, you can do it yourself, but I wouldn't recommend it. I've managed to break some toilets in the process. If there's a mechanism like the old one in there, it's literally a 5-minute job, and it's very easy.
When you say any shop, you mean Builders Warehouse, Plumlink, anything like that?
It's not available at Builders Warehouse because of their stock keeping unit process at Builders or Massville, but they are available at Chamberlain's, Plumlink, and I think they're soon going to be available in Cashbuild as well. And I think they're on the shelf for $150 for the outlet valve. And just to get back to that building that used to consume 30,000 liters a day, we did this conversion. We dropped their consumption to less than 5,000 liters a day. So that's more than 75% drop in consumption just by changing the toilets. So again, getting back to the options or the 5 things that you can do. Now, we sorted out the irrigation, and then the big drop in consumption was from the toilets. So now, if you then look at all of those efficiency devices, next thing is what you can do is aerators. I don't know if you know anything about aerators in your taps.
I know some taps have aerators built into them, and that is how it is sold to us. But again, if it's not pretty enough, we don't really use it because we don't fully understand the long-term impact, or it doesn't really affect us. I think architects' responsibility ends, or we think it ends, when construction ends, and we should take ownership of it for longer than that. But we don't know really how it works and what the impact is.
Yeah, the nice thing about it is it's not going to cost you extra capital. It's actually going to be cheaper to do it the right way from the beginning. And like I said, if you go old school, what we've done now is in some of the sites, we've actually increased the size of the cistern. That 27-liter cisterns, we make it bigger because your toilet cistern becomes a backup tank. Instead of installing a big backup tank at your facility for sanitation purposes and having pumps and tanks to flush your toilets, you've got, and you cannot do it with an in-wall gibbered system. You can do it behind the wall in that cavity. You've got much more cost-effective flushing mechanism, and it's cheap to maintain. You can train your maintenance staff on site to actually exchange these every year, where you cannot do that with a gibbered. You need professional guys to actually come in, shut off your bathroom, and do maintenance on the toilets.
I assume you then continue to flush these systems with fresh water, because that's another issue we have, is we have backup storage tanks, but then the water gets so old that you can't really use it. So obviously then the system flushes itself and keeps itself high enough. Do I understand it correctly? It keeps the water level high, but yes, you only use the little you need.
Yeah, obviously you top it up from it's like a first in, last out.
Yes.
You know, so you top it up from the top and you flush from the bottom. So there's a constant new feed in. But when you do have a water outage, then your toilets is actually self-sustainable, or they've got their own storage for 2 or 3 or 10 flushes.
Yeah.
Without having a pump system to pump the water in there. So again, understanding your flow profile from the monitoring. If you've sorted out the irrigation and you've done the toilets, you do the toilets in one day, you can see the immediate effect from leaks, from anything the next day already. And then you start looking at aerators and the taps, which is also, it's a 100 Rand per tap solution that reduce your flow in your tap from 14 liters a minute to 1.4 liters a minute. And it's actually more effective because it's got a sharper, smaller stream. It's not an aerator that fills the stream with air and actually makes it inefficient. It's got a few thin streams, and it's more effective than normal taps, but it's 90% consumes 90% less of. Now that's not applicable to all taps. You don't want to put a thing like that in a canteen or a kitchen at the office, because it's going to take you 2 hours to fill the kettle. But there where you want to wash your hands, or at a school where it's just hand washing, that's perfect for that. Or at home where you've got kids and the basin where you do your brushing your teeth, it's more effective to rinse your toothbrush, and it makes a hell of a difference in total consumption from that tap.
Is that a retrofit fitting you add to the front of the tap then?
You know, if you look at most of the taps, the fancy ones that most of the architects will spec, it's got a screw in at the front end,
yeah,
where the water comes out, and that's normally it's already fitted with an aerator. And the aerator inside, you've got that little screw in that goes into the front of a tap, and the aerator you put in there is interchangeable because it scales up, and you need to be able to change it. And it's basically just this small insert that you change. And I mean, if you spec a 4,500 Rand tap, put in 100 Rand new aerator, it's not going to break the bank, but it's going to pay for itself within the first month. The building starts operating.
Where do we find this? Is it an off-the-shelf item? Is it where do we find it?
This is also the ones that works the best, with the best quality is produced by Newpol. It's a Swiss-German company. There's only one distributor in South Africa, but it's Water Connections in Cape Town. We are also distributors from them, but you can get it from builders. You know, it's not you have to have connections now to get the right stuff. If you spec it on a sanitary schedule, it's freely available. It's not like you have to import it, and there's a lot of stock in South Africa. You can also get aerators and efficiency devices, shower heads and all that stuff at builders and Plumlink and all those guys. So we are in talks with most of them as well to start using the Surplus Water 2025 logo for efficiency devices, like Lesico that makes toilet pans and urinals and basins and taps. They've started using the Surplus Water logo because they already put the super flush light in some of their toilets. So you can buy a toilet that's already fitted with this outlet valve.
So from a specification point of view, it's not necessary that we use specific suppliers, because it's a problem for us. We have to encourage the open market. But it's a great solution for us to actually have items that you can retrofit to give you the result you are looking for. I think, let's go back to like a kind of summary. It's if you address the irrigation and your flushing mechanism on the toilets, whether it's old or new buildings, it's the same. And then if you put aerators on strategic taps, those are the three main things we should do to buildings anyways, any given day. Is there anything else? For me, that's all the water a building can use.
Now, there's one other big culprit that is in some of the buildings, and that's water-based cooling towers. When you've got a central cooling system on the roof of a building, office buildings, a lot of the old ones, even a lot of the new ones, they've got a water-based cooling tower. and I'm not going to go into the mechanics of that, but how it basically, it uses water to cool the air and to cool the central, the HVAC system of the building. Now what happens is, because you're using evaporation, the water, the mineral concentration in the water sump of that cooling tower becomes concentrated, so it needs to have a system where it gets rid of that concentrated water and tops it up with fresh municipal water to keep that concentration of the salts building up in the water as low as possible. That's why the quality monitoring on HVAC systems is also crucial, because you need to know when to activate that blowdown, get rid of the water, and top up with fresh water. Now, obviously, humidity and all that stuff plays a role, and the less humid it is, the more water evaporates into the air, and obviously then it needs to be topped up with more water as well. A lot of these systems run at a small, normal 4 or 5 story office building, 1,000 square roof. They use it's 1,000 liters an hour water evaporating. And now what happens, if you don't switch off that system at night, your aircon, it not just eats power, it actually keeps on evaporating water at 800 liters an hour. Now, we've had sites that we've just installed a timer on the HVAC system on the cooling tower, and we've saved them 17,000 liters a day, just because it switches off at night and over weekends and not continuing evaporating water. That's one of the things that happens. And another stupid thing is a ball valve filling up that sump of the cooling tower gets stuck, and it actually continuously overflows, and nobody knows that it's overflowing. And you can only pick that up and know about it once you've eliminated some of the other things and you see there's still a constant flow. So it's not necessarily a leak in the ground, but it's somewhere, something like a under-counter geyser we found. That's just a Latco valve that's broken, and it's throwing 1,200 liters an hour down the drain that you don't know about. So cooling towers is a big culprit. And then obviously under-counter geysers, and another one is reverse osmosis systems. That small domestic systems that you've got at the office, in the kitchen, or at the house, with a small faucet with the tank underneath the zinc. That thing can waste between 3,000 and 10,000 liters a month because of the mechanics of how it works. And you don't necessarily have to go into the technicalities, but there's a lot of details. I've actually made a little YouTube video on how it works and why it wastes so much water, so you can go and have a look at it and see.
I'll share the link in the video, in the video notes as part of this video.
So and that's why if you take all those aspects influencing water demand, and if that's under control, then you get buildings that your toilet consumption is between 40 and 90% of your consumption of your building.
Sure. Let's go way towards the other side with regards to storing water. I know we've discussed it in the past. Is it possible for us to have projects that are completely off the water grid? Is that a feasible thing to do? Can one store water effectively and then reuse it in a sensible way? What are your comments on that?
Yes, and that's where we come from, following this approach now, from getting your efficiency sorted out first. With that building example that I've used in the beginning of being a 100 kiloliter a day building, if you implement all of these stuff and you cut out that waste component, 80% waste, you can reduce a 100 kiloliter building to a 20 kiloliter building. Now that starts playing a role when you need to store water. All your water storage facilities, if you need to have a 2-day municipal backup system for a 100 kiloliter building, it means you need 200,000 liter storage on site for 2 days municipal backup. If you bring it down to 20, it means you need 40 kiloliters on site. That's 80% in. And tanks, if you look at sectional tanks, zinc alum tanks is bloody expensive. And if you don't have to put in 200,000 liter sectional tanks, but only 40, and you still have a 2-day backup, why wouldn't you do that? And that's where I say that the 80-20. Spend more time on sorting out your efficiencies, and the big capital that you have to spend is going to come down exponentially. So then you've got your water storage on site, which is significantly smaller. That site that I said that we've converted the toilets and dropped them from 30,000 litres a day to 5,000 litres a day. We've installed a 40,000 litre tank there, and they run for 8 days on 40,000 litre backup, where normally it would have been just over a day. Now, if you do that, now you've got the monitoring, so you know exactly what your consumption profiles for your building is looking like. You know when the peak flows are, when it's lunch, when it's tea time. You can see exactly where the flow profiles are. So your tank and your filtration components is also design specific. You know this is a 4,000 litre an hour peak building. So your pumps and your filtration need to be able to do that 4,000. What happens in the past is they do a thumb suck and they say, let's put in 2-day backup. We work on this and this per head, 25 litres per person, but there's so many group. So this is the size of the tanks. We're going to use 200,000 litres a day. So let's put in this tanks or pumps that can do 20,000 litres an hour. So it's totally not backed up by data and bloody expensive. If you look at that components, the tanks, the pumps, the filtrations, it's ridiculously expensive. And the higher you need the output from those systems, it becomes exponentially more expensive. So a 2,000 litre an hour pump is not half the price of a 4,000 litre pump. It's 3 times cheaper than, so the storage, getting to that is once you've focused on the efficiencies, your storage and your design, there's actually a design behind it, and to say this is what we need. Obviously space constraints, you've got smaller tanks, energy design for solar systems, the thing is not as energy demanding as a big system. And then you've got your 2-day municipal backup system. And then only we start adding alternative water, like rainwater and borehole water and all that stuff. And there's absolutely no way that you can get any building 100% off the water grid. That's assuming your water grid consists of borehole water, rainwater, and municipal water. People drill a borehole and they get off the municipal grid, but they're so bloody inefficient with their borehole that if everybody does that, we're going to run out of groundwater in the next 2 years, which is starting to happen. So I fully support groundwater, but then still do the whole efficiency drive so that you use as little as necessary groundwater or rainwater or whatever as well.
Oh, well, great. The one that adds on to that is, do you ever harvest any water that runs over roadways? Do you cash in on those surfaces, or is it something you try to avoid on a similar way as trying to avoid storing rainwater?
Yes, you say, there's a saying that says there's no better engineer than a lazy engineer, a lazy one, and I think I'm pretty lazy. I don't like maintenance, and the moment you start or having sources where the water comes from that you can't identify, you need to obviously design for worst case. You need to be able to take out oil, and that's a very difficult, expensive, maintenance intensive process. You need to be able to cater for, it becomes, the variables becomes too big. So what you do is you need to, and again, when you start from an efficiency side, from a demand side, and you get a building as efficient as possible. Remember, rainwater, you cannot, even if it's hard surface, if you take the whole surface area of a site and you can harvest everything, it's still limited to the size of that area. So if you've got your annual rainfall, and you cannot harvest more than what falls on that specific area. It's not like solar panels that you can put more panels. This is what you have. So what you do is, if you can harvest 1 million litres from the roof of that site, that's what you can harvest. You cannot increase it. You cannot increase the rain amount. You need to get that 1 million litres to go as far as possible. You can only do that by getting your demand as low as possible. If you use 100,000 litres a day, 1 million litres is not going to take you very far. But if you reduce it to 20, that same million is suddenly taking you 30% of your total consumption and not just 5. So that's again where your efficiencies comes in, is it makes your alternative sources, your rainwater or your borehole or your groundwater, then you don't have to take the risk of doing wastewater treatment to get it back to potable, or catching water from hard surfaces with oils and with spillage and with chemicals and with all that stuff. You eliminate that risk immediately, and you focus on what is in your control, and do that and maximize what's in your control by sorting out what you can by the demand. And that's that whole 80-20. I mean, if you get your site so low, sometimes it's not even necessary to look at alternative sources, because your consumption is so low that you've got your municipal bill is almost irrelevant, because there's two components to a municipal bill. It's the water and the sanitation. The less water you consume, the less your sanitation component is too. So now people look at wastewater treatment to get that back to potable. But it's, once you do the efficiencies, you don't even have to look at wastewater treatment, because it's expensive and it's risky.
Yeah, Gary, I've learned so much today, and I really think, I thought I knew how to do it, I promise you. Are there any other tips or techniques you have for architects? I know often when we speak to people that gets to work with architects, they so desperately wish that we knew some things. Are there things you wish we knew that we would implement right from the start? Are there any other things you'd like to discuss so we can start wrapping up?
See, Annika, I think we just need to all, and that's the whole idea with the Surplus Water 2025. It's not one company or one fraternity or one part of the process or new builds or retrofits. It's everybody needs to work together to get the benefit from it. So architects can play a role. The companies manufacturing efficiency devices can play a role. Everybody's got a certain portion to come to the party with and say, and the whole, all you have to do is follow that drop principle. Watch your data, understand where you come from, refine your data, look at the options, and then proceed with the right options. And it's basically following I don't know if you heard about the OODA loop. It's basically the same principle, but it stands for observe, orient, decide, act. So you first observe, then you orient yourself towards this observation you made, then you make a decision, then you act. And it's also a positive reinforcement loop, because so many times we just jump into, this is what the data says, this is what the consumption of the building is going to be, so we need to design to cover for that. And that's just a bulldozing effect. We need to start thinking the approach. It takes slightly longer, but the long-term gains is immense. And I don't think people realize, and there's a convenience and consumption line. We get to a point where consuming more is not more convenient, but consuming less than that becomes inconvenient. So we need to get that point where anything above that convenience line is waste. And most of that is 80%. 80% of above our convenience line is waste. And by eliminating waste, we don't realize even that there's interventions. And I think from architects, I mean, we've a lot of the new builds, we spend a lot of time with the architects, because they basically from start to finish part of the project and influence a lot of the decisions. So it's just following the process of know where this building comes from and what we can do to make a hell of a difference. The knock on down the line effect of small things to put in place.
Gary, thank you very much for your time. I mean, I really appreciate this. It will definitely influence the way I think about water and water consumption in buildings in the future. Where can we get hold of you?
Our website is, all my contact details is on our website. We've got a separate website, Surplus Water 2025, where you can, as a company, as a manufacturer, can get involved with the Surplus Water initiative. It's a registered trademark, so to start using the initiative, start using the trademarks. But all my details is on our website. Is www.aquafection.com. And yeah, make contact. And like I said, we've got a training department. For me, it's all about, I don't think people realize how big the issue is with regards to water in this country. And we cannot fix it as a company. The opportunities are so big that we cannot, it's impossible for us to solve the problem on our own. It's going to be a collective effort. It's not about making money. It's about almost as bad as saying it's about survival. If we don't do it together, we're going to be in serious trouble. We're already 15% using more, 15% more than what can be supplied for the next 11 years. So we're in serious trouble, and we have to work together, and it's not just for survival. The financial benefits of it is also substantial. But to focus on, let's get this country and this stuff sorted out as a collective, and then we'll all be better off. So you cannot afford not to do it anymore.
Thank you very much for attending today's CPD. If you like what you saw, please let me know. If you didn't like what you saw, please let me know. The aim is to create high quality online content that we can consume from our houses. We don't need to drive anywhere anymore. We don't have to spend full days on CPDs anymore. And I really encourage everyone to give me their feedback, to give us your feedback. Encourage anyone to start generating CPD points. I think we can all benefit from the collective knowledge we have. Please send me an email to anneke@schrik.co.za, and I hope to see you again with any of my other interviews. Thank you very much.